So in the last live session, we started discussing how we actually design a FRP based on the requirement of strength for an existing infrastructure. In this, we first discussed flexural strengthening using FRP. So we know the basic equation: phi times mn should be greater than mu. Okay, this equation simply says that if we consider material degradation over time, then still the nominal strength of member after retrofitting should be greater than the ultimate required strength after load increment. Okay, we saw basic stress strain diagram, how FRP retrofitting is adding its own value to the member, and we saw a numerical of FRP design going in a step-by-step approach from structure check to material degradation parameter, then determining the existing material properties and strain level, then determining the effective stress and strain level after FRP, and finally checking for strengthening if the FRP provided is adequate or not. Then we discussed shear strengthening using FRP. So here we again saw the basic equation. We all know that concrete, steel, and FRP will all contribute to the shear strength. So that strength accompanied by the durability reduction factor for FRP and additional strength reduction factor for the entire assembly should be greater than the ultimate required shear strength after load increase. Okay, so we saw this basic equation, and then we talked about how different types of shear wrapping and the angle of wrapping uh, is taken into consideration, and we saw equations where these things are considered while designing. And then we step by saw a numerical on FRP shear design, going in a step by step approach from first structure check, then material degradation parameter, then determining the effective strain in FRP shear reinforcement, then determining FRP contribution to shear stress, and finally checking for strengthening whether my shear reinforcement that I provided was is enough or not. So last time we saw a numerical in which we initially provided a two-sided strips, but we on the final check we observed that those strips were not sufficient, so we changed from two side to U strip, and then when we again check that U strip was sufficient. So this is how we proceed for the design of shear member using FRP retrofitting. Finally, we discussed axial strengthening using FRP. So axial strengthening means confinement, okay, of existing column. In this, again, we saw a basic governing equation which is similar to other cases. Okay. However, in axial strengthening, the mechanism of action is different. The FRP shows its effect only when the existing infrastructure fails to take load. In other word, if we in other words, upon load action, the concrete fails first, which causes FRP to exert confining stresses and show strengthening behavior. This is the working phenomena behind FRP retrofitting for axial members. Here we saw a stress strain diagram, which is a bilinear diagram in this case. Okay, here the initial parabolic portion represents the concrete that is under axial load, and the later on linear portion represents the FRP when it takes control after concrete failure. In this also we saw one numerical of FRP axial strengthening of column, going in a step-by-step approach from initial structure check whether the structure is sufficient to take FRP strengthening or not. Then we talked about material degradation parameter, determining this phi parameter. Then determining the compressive strength of confined concrete, determining the required confining pressure from FRP, and then final design and check for strengthening. Okay, so this was all that we discussed in the last session. Now, till now, the discussion we had on repair and retrofitting was mostly oriented towards building and major infrastructure projects like bridges. Okay, today we'll see a different category of infrastructure, that is pavement. Okay, so basically, what are pavements? So pavements are a structure that carries foot load or vehicle load. Okay, and they find broad application in construction of highways, urban roads, parking areas, and low volume roads. So as can be seen in the image, you can see this. These are low volume roads. These are parking areas, and these are major uh, uh, transportation roads. Okay. So here we find application of pavements. Pavements are broadly classified into two types. There are bituminous pavement and there are concrete pavements. Okay. So before moving into repair, we shall see some basics about the pavement also. What does both of these pavement mean? How they are damaged, and then we'll see the repair part so that we can get a better clarity of repair actions. Okay, so first is the bituminous pavement. These are also known as flexible pavement. Here, bitumen act as a binder for coarse aggregate, and thus it is known as bituminous mix or an asphalt mix. Okay, how bituminous pavement work? It works in a layered structure. So they are arranged in the order of descending strength and the load carrying capacity, and it basically consists of four layers. There is surface course, there is base course, there is sub base course, and there is subgrade. Okay, so the load, each layer receives load and it spreads the load and transfers the load. So if I draw the front view of this, so it will be like this. Okay, on the top, on the top layer my load will be acting in this much area and it will slowly spread the load. Okay, so as the load will spread, the pressure that has been exerted on the below layer, it will be lower and it will be able to take the that load because its strength is also lower. Okay, thus we say such kind of load transfer as grain to grain contact transfer. Okay, now these kinds of load have less flexural strength and they carry on load like a flexible sheet. Okay, being flexible, they ought to have a better quality to sustain most extreme compressive stresses like wear and tear. Okay, and typically each layer bears some critical load and crack in pavement are clearly appeared at the surface. So each for each layer there is a critical limit up till which it can sustain the load, and when that critical limit cross, the layer fails and those cracks generally appear at the surface as a form of reflection cracking. Okay, and the second type of pavement is concrete pavement. These are also known as rigid pavement. And as the name suggests, here cement act as a binder for coarse aggregate minerals. Here, there are not many layers of material, as there is only one single layer between concrete and subgrade, and this layer is known as base or sub-base layer. Okay, so in bituminous pavement, we saw there are four layers, while in concrete pavement, there are only three layers. Okay, and how load transfer occurs in this? It occurs through plate theory. So load is transferred through slab action and the road behaves like an elastic plate resisting on a viscous medium. Okay, so this concrete slab, it generally resists the maximum amount of load, and very less amount of load is transferred till the subgrade. Okay, it is capable to transfer wheel load to a more extensive region as it has good flexural property, and the concrete slab when rigid experiences twisting and bending action due to temperature and vehicular load, and thus they are equipped with transverse joints and longitudinal joints. So since concrete is rigid material, it can experience some bending stresses also due to temperature and low vehicular load, and that's why we equip it will provide some joints, transverse joint and longitudinal joints to resist those cracking. So here you can see these are longitudinal joints and these are transverse joints that are provided in a concrete pavement. Typically concrete base carries the maximum load as we talked earlier also, and the subgrade contribution becomes less important. Okay, so this is concrete pavement. Now, based on the application, load, and environmental conditions, the pavement experiences different types and intensity of stresses. Okay, and the end result of these stresses are distresses in the pavement. Okay, there can be several reasons for distresses in pavement, which are repetitive loading due to moving vehicle, which can cause fatigue stress. Okay. Second is overloading of vehicle, which causes exceeding the limit of ultimate strength of pavement. Third is temperature and moisture effect, which may generate shrinkage and tensile stresses. Fourth is subgrade failure, which lowers the strength of pavement, more importantly in bituminous pavement, and in turn it reduces the ultimate strength of the pavement. Fifth is the defoundation movement, which can generate differential stresses and settlement in the pavement. Sixth point is material degradation, which again lowers the ultimate load carrying capacity of pavement, and it can be critical in both bituminous and concrete pavement. Seventh is joint failure, which results in stress concentration and can provide easy pathway for critical failure. And finally, we have improper mix design and compaction, which again will lower the strength and stability of the pavement. So in the image, you can see few such distresses resulting from the discussed reason, like cracking, settlement. These are creasing effects. Okay, you can see spalling that is occurring near the joint, wear and tear that is occurring due to repetitive movement of vehicle, and map cracking also in case of concrete pavement. Okay, now, just knowing different reasons behind distress is not enough. We shall also be able to visualize those distresses and categorize the distresses so that we can choose a proper remedial measure later on. Okay, so first in bituminous pavement, because of previously mentioned reasons, distresses can be classified into nine types. So these are alligator and fatigue cracking. So they appear as a series of interconnected cracking, and they are caused basically by repetitive vehicle loading, overloading vehicles, subgrade weakening, and aging of bitumen. Okay. Second is reflection and block cracking. Okay. They appear as a series of sympathetic cracks. Okay, as shown in the image. And they are caused basically due to joint failure, subgrade differential movement, and thermal and moisture ingress. Okay. Then we have rutting cracking. So they appear like a longitudinal depression along the wheel path, and they are mainly caused due to heavy traffic and low overloading, or it can occur due to weak subgrade, improper mix design, and inadequate compaction. So both of these things, in improper mix design and inadequate compaction, will lower the strength of the pavement, and due to which the traffic and overloading will cause such depressions. Okay. Fourth one is corrugation. So in the rutting cracking, we saw there were longitudinal depressions. Here there are transverse depression, or we say regular undulation across the surface. Okay, these are again mainly caused by lack of mixed stability. Okay, in which there can be excessive binder or high proportions of fine, which can cause such instability in the pavement, or faulty laying of surface course can again result in corrugation, or insufficient compaction can again result in corrugation. Okay, then we have longitudinal cracking, which occurs along the length of the road, and they can cause due to wetting and drying cycles of moisture or improper or weak joints. Okay, so along the joints, we can see such cracking if they are not of good strength. Okay, similar to longitudinal cracking, we have transverse cracking also. So these cracks are along the transverse direction, and they are basically caused by surface subgrade failure, bitumen aging, and low temperature bitumen shrinking. So they are mostly found in bituminous pavement, and they appear like in the horizontal direction, cracks along the transverse direction. Seventh one is polished aggregate, or we can say abrasion cracking. Okay, so they are basically caused by wear and tear of exposed aggregate, and they occur mainly due to heavy traffic, repetitive loading, and bitumen failure due to abrasive action. Okay, then we have potholes. Okay, which are basically localized degradation of material. They can be caused due to loss of adhesion of bitumen due to water ingress, lack of bond between bitumen or subgrade, and insufficient bitumen content. So such kind of damages are most commonly found in bituminous pavement due to uh, weak bitumen layer. Okay, then we have bleeding. again in case of bitumen, where we see a thin film of excessive bitumen all over the surface. Okay, and it is caused due to faulty mix design where excessive bitumen may have used, or soft grade bitumen which may not be able to set properly, and low voids in uh, hot mix that also led to bleeding of bitumen. Okay, so these were like several reasons by which in which distresses in bitumen appears, in bitumen pavement appears. Okay, now if we see concrete pavement, so there can be uh, there can be different types of distresses again. So these distresses in concrete pavement are classified into eight different categories. So we see corner cracking, okay, which develops due to localized high stress development, and they are caused basically by repetitive loading, excessive loading, drying shrinkage, poor grade, subgrade, and poor load transfer through the joints. So such cracking are often seen near the joints and in terms of blistering of concrete members. Okay, or in near at the end of the road also we see such cracking due to repetitive loading or drying shrinkage problems. And we have longitudinal cracking, the same as bituminous pavement. These are also along the length of the road, and they can occur due to large joint spacing, poor compaction of subgrade, sudden settlement, drying shrinkage, and thermal and moisture ingress. So these all can be different reasons in which longitudinal crack may appear. Then we have transverse cracking that appear across the length of the road. Again, here large joint spacing, overloading, sudden settlement, drying shrinkage, and incorrect location of transverse joints are the reasons behind the transverse cracking. So we see here longitudinal cracking, the orientation of longitudinal joints is very important to resist this. While for transverse cracking, the orientation of transverse joint becomes very important. Okay, spalling at joint, again as cracking at joint, we can also observe spalling of concrete near the joint. Okay, which can again occur due to repetitive loading, excessive loading, and defects in joint and load transfer. Okay, faulting at joint, which appears like a settlement near the joint, and we say it as a relative vertical movement at joint. They generally occur due to internal erosion due to water ingress at joints, mainly transfer joints, or subgrade settlement or overloading near longitudinal joints. So across different types of joints, different reasons can be there for settlement near the joint. Then we have blow up joints where the concrete near the joints completely blow up. Okay, complete collapse of concrete near the joint, and they appear occur due to excessive expansion due to thermal and moisture movement. Okay, so when there is a lot of thermal expansion within the concrete, there such kind of blow ups can occur near the joints if the joint spacing is not provided adequately. Then we have pop outs, which are localized damage in concrete. They can occur due to poor mixed design of concrete, thermal expansion, freeze and thaw, and adequate compaction. Other reasons can be excessive loading or impact loading that may have caused due to some action at the roadways, which can also cause such pop up joints. And then we have punch outs. Okay, so punch out, they appear as a part of slab that is broken. So this is one slab, okay, and one part of slab got completely broken. This is known as punch out. So they are mainly caused by formation of many small cracks near the joints, which ultimately lead to such punch out. They can also occur due to loss of sub base support and maybe due to steel corrosion. Okay, so these can be different reasons for distresses in concrete pavement and how these distresses can appear on a concrete pavement. Now let's see a simple question here where you need to identify the distresses shown in the image. So I will give you a couple of minutes. You need to guess what kind of distress are mentioned in each of the image, and then we'll see the answer. I will mute myself for a couple of minutes. In the meantime, try to solve this question, and also if you have any query, try to write that query in the chat box. Okay, let's see the solution to this question now. Okay, so in this image, the first image was showing the rutting cracking. So as you can see in the form of depression. Okay, second is corner cracking. Third are potholes. Okay. In fourth, we see polished surface and corrugation both because there are depressions along the across the road, and there are some wearing and tearing and shiny appearance of aggregate polish aggregate. Okay. These are longitudinal cracking. Okay. And these are reflection or block cracking. Okay. So, just knowing the cause of distress is not all enough. You also should know what type of distress it is so that we can choose a adequate repair for it. Now, knowing the pavement type, distress reason, and distress type, for proper choice of repair, it is also important to evaluate the severity of distress in the pavement. Okay, and this can be drawn by evaluating the active or the current performance of the pavement. So, as we know, pavement degrade over time due to several reasons like aging, loading, poor design, etc. And thus, it becomes necessary to evaluate the performance of pavement periodically. Based on this evaluation, we can in turn determine the need of repair and retrofitting required for the pavement. Now, how do we quantify performance of a pavement? Okay, so this can be done in two ways, either by looking at the functional performance of the pavement or by looking at the structural performance of the pavement. Okay, so by functional performance, we mean something that is related to the comfort, safety, and economical riding experience. Okay, and this is affected by surface condition, roughness, and the skid resistance of the pavement. While by structural performance, it is related to the structural capacity of the pavement, and this is affected by in situ strength of different layers and the load carrying capacity of the pavement. If we relate this to our previous discussion that was done in week 3, live session, so we can say functional performance is nothing but durability, which generally gets affected, which when get affected requires a repair. Okay, so we saw functional performance, it is more related to comfort and it can be seen as a durability repair. Okay, while structural performance is more like a strength reduction and need for strength increment, for which we can think of a retrofitting kind of thing. Okay, now, for evaluating functional performance of the pavement, there are two ways, either by using visual inspection. Okay, so in visual inspection, you can there is visual survey of pavement that is done in a walk and drive manner. Okay, this involves the identification of location of distresses and determining type, extent, and severity of distress. How we can do this? For example, the amount of cracking, rutting, and pothole area we can be determined in terms of meter per square and meter per kilometer and meter square per kilometer classification. And based on this, we can comment on how severe the damage is there in the pavement and what are the different location where the pavement has got some distress. Okay. Now, uh, and the second type can be instrumental inspection, where there is straight edge measure which can be used to quantify rutting. There can be bump indicator which can be used to quantify corrugation, and there is profilometer which can be used for all pothole, rutting, corrugation, and polished aggregate together. So in this way, we can assess the damage at the surface level of the pavement. Okay. While for evaluating structural performance, we have semi-destructive testing like core extraction and testing. So in this, what we do, we take a core from the pavement. Okay, we collect the core sample and then we test those core sample in lab for compressive strength or for deflection. Okay, so these are core extraction and testing. Apart from the compressive strength, we can also do collect some small chunk of samples and do petrographic analysis if you want to know the composition of the pavement, or we if we want to check the quality of the material that were used in the pavement, so for that we can go for petrographic examination that we discussed, I guess, in the week 2 or week 3 of the course. Okay. And then the second method of semi-destructive testing is trial pit assessment. So this can be used for collecting pavement or soil samples from various depth. Okay, here we saw only at a single location we are collecting the sample. However, through trial pit we can collect samples from various depths or the various layers. Okay, and they can be used to study crust composition, determine the strength of the subgrade, or to characterize the underneath soil by for different properties like grain size, density, and moisture content. Okay, so here in the image you can see a trial pit was dug on the bituminous pavement, and later on it was used to uh, check different layers of those pavement. Okay. And we also have non-destructive testing, in which a static and or a dynamic load is applied on the pavement and response is recorded. So the response generally means deflection, which later is used to back calculate the in situ strength parameter of the pavement. Okay, among NDT, the two most commonly used are plate load testing, where a load is applied on a fixed cross section of the pavement at a defined intensity and for defined time period, and then the deflection is recorded using steel gauge or LVDTs. Okay, here again we can conduct PLT either as an NDT on the surface as shown in this diagram, or it can be combined with the trial pit to assess the underneath layer strength. Okay, as shown in this diagram. So here you can see at the surface only plate load testing was used, and using deflectiometers the deflection was recorded, while here you can see a pit was dug inside the pavement, and then at a subsequent depth PLT was conducted to assess the quality of the underneath layer. Okay. The second and the most commonly used NDT is falling head deflectiometer testing. So this is used to evaluate several parameters like strength, estimation of different layers, estimating remaining life of pavement, determining strengthening requirement, and estimating joint performance. How does this testing work? So in this impulse loading device is used, which can simulate load of a moving vehicle. The load is applied on the pavement by dropping a fixed mass from a predefined height. So we drop a fixed mass of load from a predefined height on the pavement. Okay. The falling mass drops on a spring connected to a circular load bearing plate placed over the pavement. Okay, so this load that is dropping, it drops on a spring plate. Okay, as this load drops on the plate, this spring exerts load on the pavement. Okay, under the action of impact, the pavement experiences deflection in the form of bowl. So, since we are applying load at a single point, this point may deflect more. However, this point may deflect less. So, in this way, a bowl kind of deflection is formed on the pavement. Now, to record these deflections, several displacement sensors, which are also known as geophones, are placed at different locations from the falling mass to collect deflection data. So, from this location, at different distances, we place displacement sensor and record the displacement. And the load and the deflection data that is collected by a data acquisition system, which is used later on to analyze the strength of the pavement. Okay, so the same can be visualized in the figure. Here, we have to define the loading area, falling mass, falling height, peak load, and the loading time. And based on these and the geophones that are placed at different locations, we will measure the deflection that occurred in the pavement due to the falling mass. Okay. The same can be seen in the figure also for applications. Here you can see different displacement sensors are placed at different location from this falling mass. Here also you can see only at one location they are performing the FWD testing. There is only one displacement sensor. Okay, and here you can see it is the FWD is equipped like a moving cart on a vehicle to test the pavement at different location. Okay, so basically we input this load versus time profile. Okay, on the pavement through the FWD DAS data acquisition system, and through geophone we get the deflection versus time profile. Okay. In addition to this, knowing the other inputs like layer thickness, Poisson's ratio, different layer loading area of plate and radial distance of geophone, we can finally estimate the modulus of elasticity of different layers using back calculation. Okay, so this is how FWD testing works, falling head deflectometer. Okay. Now, once we know the type of pavement, distress in pavement, extent, and in the extent of damage due to distress, we can go for repair. Okay, so for pavement repair, the one of the most commonly used technique after obviously filling the cracks that occurred due to distress is the via concrete overlay. Okay, so this technique is more often used in retrofitting purpose rather than repair. Okay, so they are most commonly used for retrofitting, or in some cases they can also be used for repair. But mostly for repair purpose, our first primary task is to fill the cracks either by grouting or shotcreting based on the extent of damage. Okay, so in concrete overlay, it involves applying a new layer of concrete to the surface of the existing pavement. The goal is to increase the total thickness of the concrete slab, thereby reducing the wheel load stresses and extending the pavement's life. Okay, it offers benefits like increased functional capacity, less maintenance, smooth riding, less fuel consumption, reduced urban heat island effect, enhanced durability, and low life cycle costs. So these are some of the major benefits that comes due to concrete overlay. However, there are also some challenges like need for proper designing considering vehicle load, existing pavement condition, geometric constraints on the side, because since we are increasing the level of the road, then there can be some problems to the residents near the road. Okay, in terms of like water seepage may start occurring in their homes, so such kind of geometric constraints also come when we talk about concrete overlay. There can be climatic conditions which can be a constraint, or there can be constraint regarding the desired service life, whether we are able to provide that service life or not based on the concrete overlay method. Okay. Now, for concrete pavement, the concrete overlay can be of different types. They can be bounded, partially bounded, or unbounded concrete overlay. While for bituminous pavement, we have conventional white topping, thin white topping, and ultra thin white topping, which are used for as a concrete overlay. Now, when we talk about overlay for concrete pavement, there are two choices, either bounded or unbounded. So, as can be seen here also, in unbounded overlay, there is a separate layer existing between the pavement and the concrete overlay. Okay, so this is a layer which is separating the overlay and the existing pavement. Okay, here both layer are independently acting to resist the load action as shown in the graph also. So this is the overlay layer and this is the existing pavement. So these both will act independently. It will act as an individual unit, and this will act as an individual unit to resist the load. While in bonded overlay, the overlay concrete is perfectly bonded with the existing pavement along with the synchronicity along the joints. Here you can see the transverse joints and longitudinal joints are also uh, uh, like overlapping each other, which is an important part of concrete pavement, so that it has a bounded interface. Okay, and in case of concrete overlay, both layer act together to resist the action of load by distributing stress. So you can see in the image also the tensile stress due to the acting load, it is lower now near the base of the overlay, because there is stress distribution across the total depth. Both layers are acting together to resist the load. Okay. Now the question comes here, how to make the choice, which type of overlay I need to choose. Okay, so this depends upon various factors. The most important one being the extent of distress in the existing pavement. So if we see concrete pavement overlay, there are three types of overlay: bounded, partially bounded, and unbounded. The basics of each overlay is: in bounded overlay, the overlay is fully bounded; in partially bounded overlay, the overlay is partially bounded; and in unbounded, it contains a separation layer between the overlay and the concrete. In terms of thickness, it is 75 to 100 mm thick. The second one is 150 to 200 mm thick, and the third one is 150 to 300 mm thick. And the aim of bounded overlay is to is to have a proper bond which enables adequate load transfer and allows pavement to act as a single unit. While in case of partially bonded overlay, it is used when bonding is not very important, and thus it can show reflection cracking, because if there is some cracking in the sublayer, it may appear at the surface because both units were not acting together. Okay, though my surface has not filled, but still some cracking may appear at the surface due to reflection cracking. And in unbounded overlay, both layers act as a separate unit, and thus there is not much reflection cracking issue in this. Okay, now how we make the choice whether to use bounded or unbounded, it depends upon the extent of distress in the existing overlay. So if the existing pavement is in relatively good condition with no material distress, we use bounded overlay, because that existing pavement can also support the bounded overlay, that can also support the overlay material, and thus they are bounded together to act as a stronger unit. While in partially bonded overlay, the existing pavement is in fair to moderate condition, and in unbounded overlay, the existing pavement is in fair to poor condition with little or no remaining life. That's why we have an unbounded overlay, because I don't want support from the lower layer as it won't take load. So that's why I'm separating the two layers. Okay, this is my top layer, it will take its own load, and this is my bottom layer which will take its own load. Since this bottom layer won't be able to take much load, we need a very strong unbounded overlay layer. That's why here the thickness is also much higher compared to the bounded overlay. Okay, now, based for what are the requirements for each of these type? In case of bounded overlay, surface preparation becomes very important, because we need bonding between both overlay and the existing pavement. While in partially and unbounded overlay, surface preparation may be required or may not be required, since my overlay layer is acting as an independent unit. Okay, for providing adequate surface, we use pre-overlaid repair and bonding agents, while here pre-overlay repair and bonding agent may not be needed. Okay, and matching the joints are necessary in both bounded overlay and partially bonded overlay, so that load transfer can occur adequately. However, in unbounded overlay, matching the joints, the transfer and the longitudinal joints are not that necessary. Now, in case of bitumen pavement, we provide white topping overlay. So these are generally cement overlay which are constructed at the top of the distressed bituminous pavement. They provide benefits in terms of longer life, low maintenance, low life cycle cost, and environmental benefits by reducing the urban island heat effect. Since it is white in color, it will be able to reflect heat and it won't absorb that much heat. Okay. Major deformations like rutting and cracking in bitumen pavement is resisted by concrete overlay. The white color offers stability against heat island effect, reflecting more heat rather than absorbing. So in this image, you can see a white topping overlay has been used for bitumen pavements. Okay, again the choice depends upon various factors. Okay, the most important one being the extent of distress in the existing pavement. So we have a conventional white topping, we have thin white topping, and we have ultra thin white topping, which can be used as a overlay in case of bitumen pavement. Here, in the first one, there is no debonding layer, while in the thin and ultra thin white topping, there are composite action. Like both bitumen pavement and the white topping act as a single unit. Okay, the thickness in case of a conventional white topping is greater than 200 mm, while in case of ultra thin white topping, it is 100 to 200 mm, and in case of ultra thin white topping, it is less than 100 mm. Okay, the aim of conventional white topping is that existing bitumen surface act as a subbase without considering any bond with the overlay. Okay, so here my concrete is the base now, while my bitumen act as a sub-base to that concrete now. Okay, while in thin white topping, bond is considerable but not mandatory, and it uses high strength concrete overlay. So for thin white topping, we generally use high strength concrete overlay, and bond may be considerable or may not be. While in ultra thin white topping, it must be bounded to the bitumen, and it again uses high strength concrete overlay. Okay, now which overlay I need to choose, it depends upon the extent of distress. Okay, so for heavily damaged bitumen pavement with excessive rutting and cracking, we use conventional white topping. The reason is similar to what we discussed in the concrete overlay. Since my existing pavement is in critical condition, it won't be able to take much load. So we need a separate unit at the top which can take that load, and thus we use a conventional white topping with the higher thickness which can resist the traffic load that are coming from the top. Okay. And then there is thin white topping in which the existing bitumen is in fair condition without any white cracks or without material degradation. While white topping, it is used when the existing pavement has low volume of material deterioration and where my existing bitumen can also contribute in strength. Okay. So for conventional white topping, I may not require surface repair and thus no pre-overlay treatments are needed. While for thin and ultra thin white topping, I require extensive surface preparation so that I can ensure proper bonding between the existing pavement and the overlay. Okay, here minimum 75 bitumen thickness is needed after milling. So after preparing the surface, there should be 75 bitumen thickness, minimum of this. Okay, suppose I have a 50 bitumen thickness left after surface preparation, then what I need to do, I need to increase the thickness of bitumen layer first till 75 and then I will use the concrete overlay. Okay, and in terms of joints, joints are like necessary like in concrete pavement. In all the three cases, since we are providing a concrete overlay, we also need to provide joints, longitudinal and transverse joint. The difference is, in case of thin white topping, the spacing between the joint decreases and the panel size, the rectangular panels that are created due to that joints, that should be less than 1 by 1.2, while here again the panel size should be less than 1.2. Okay. Now, for proper application of concrete overlay, there are several things that should be considered. Okay, so these are the information that are needed from existing pavement and evaluation method before designing a concrete overlay. So we should know the type and the thickness of existing layer, since this will act as a sub base for overlay and it will dictate the type of the overlay. Okay, as we talked right now also, if the bituminous pavement, I need to go for ultra with ultra thin white topping, I need minimum 75 of bitumen overlay. Okay, but if it is only 50 then I need to increase the thickness of the bitumen overlay first and then only I can go for concrete overlay. The width of the existing pavement, it is also very important since it will dictate the extent of overlay that is needed. The type and the extent of distress, it will dictate the type of overlay that is needed and the extent of surface preparation that we require. Okay, and the restrictions on finished road level. Okay, so as we talked earlier, sometimes what happens when we increase the thickness of the pavement due to overlay, there can be some problems to the neighborhoods that are residing near the pavement area. So for them, so that they don't feel any inconvenience, there are often some restriction in the finished road level that should be taken into consideration so that we can ensure proper water drainage from the pavement and comfort to the site residents. Okay, apart from this, we also need to check for presence of any harmful soils like black cotton soil, which can show expansive nature after absorbing water. We should also need to concern for the subsurface and surface drainage conditions, and we should also have a traffic survey data so that we can decide what type of overlay and what thickness of overlay is needed for us. Okay, so often when we now Often, subgrade strength becomes an important parameter when we evaluate the existing pavement and make the choice of overlay. So, generally, subgrade strength is represented in form of the modulus of subgrade reaction or California bearing ratio, and is determined either by carrying out plate load test or by laboratory investigation of soil samples collected from trial fit. Okay, so either of these methods are used to calculate the subgrade strength, which will help me to identify how much distress has occurred in the existing pavement. Okay, in case of bituminous pavement, this K value is also determined by using correlation charts that are drawn either by Beckelman beam deflectometer or FWD values. So you can see here in this table there are different types of soils that are present in the subgrade, and their Young's modulus and Poisson's ratios are listed. So these are very important when it comes to design of concrete overlay, because if we take into consideration bonded overlay, then I should know the strength of my existing pavement also and how much it can contribute to the strength. Okay. Well, here you can see load settlements curve that were made to assess the strength of the subgrade material, and you can see for different soil the settlement is different based on the increment and offload. And this is a general Beckelman beam deflection curve, so it shows how with the increase in deflection the K value of the existing pavement is decreasing. Okay. If we see each of these factors and how they dictate the design of overlay, so in case of severely degraded pavement, we often need to provide unbonded overlay where surface preparation is not very critical. However, for pavement under reasonable conditions, we provide bonded overlay like ultra thin and thin white topping, where the overlay and the existing pavement are expected to show composite action, and hence surface preparation becomes critical. Okay, so here you can see this diagram we saw earlier also, and the surface of existing pavement shall be rough to achieve adequate bonding and uniform to provide identical thickness to the throughout the overlay. Okay, and the surface condition can be influenced by several factors that we should consider before designing. There can be traffic characteristics, there can be interface characteristics, or there can be climatic conditions which can affect the surface characteristics of a pavement. Okay, so when we talk about traffic characteristics, we need to estimate the base annual traffic load or projected future traffic load either by using long term pavement performance or approach or by using traffic load analysis calculation. So in this, generally composition and magnitude of axial load, the position of axial load on the pavement, tire pressure, frequency of each type of axial load, total number of commercial vehicles per day, and traffic growth rate, all these things are taken into consideration to determine the traffic characteristics of the existing pavement. In case of interface characteristics, for fully bonded overlay, existing pavement shall provide adequate additional stiffness. Okay, and thus stress developed in the bottom of the overlay is less, and the thickness required of the overlay is less. So this discussion we already had earlier. While for bounded overlay, existing pavement has no contribution to stiffness. Thus, stress developed at the bottom of the overlay is more, and the thickness of overlay required is more. So this we know. Now, in terms of climatic condition, curling effect is observed in overlay due to daily and seasonal temperature variation. Okay, so you can see here when the temperature at the top is greater than the temperature at the bottom, then there can be upward curling, and this generally happens in the daytime. While at the night time, when the temperature at the top is lower than the temperature of the bottom, then you can see such type of curling that can occur in the slabs. Okay, the amount and the severity of these curling generally depends upon the panel size and are often restrained by adjacent slabs and the sulfate. So if we will reduce the panel size, the amount of curling will also reduce. Okay, if we will decrease this part, okay, if we decrease this part, then the curling also decreases. Okay, and in between daytime and nighttime curling, the nighttime curling is more prominent and more severe to us while designing. Okay. Now, After knowing all these things, we know the effective strength of foundation that needs to be considered. We know the location of critical stresses due to axial loading and temperature gradient, and location of axial stresses. Okay, flexural stresses can occur near the top, okay, at the corners or edges near the bottom. Okay, and these stresses they depend upon the slab size and bonding conditions. Okay, so if we have a less panel size, less flexural stress will develop, and if we have less bonding, more flexural stress will develop. Okay, and such critical stress location they can also be affected due to aggregate interlocking. And to safeguard pavement from all the such stresses, there are two theories that are commonly used. Okay, critical stress criteria, where flexural stress developed due to loading and or temperature at top or bottom or corner or edges should be less than the flexural strength of the material of the pavement. So while designing the pavement, we use this critical stress criteria to take care of all the such stresses. While this fatigue criteria, which says that pavement should be able to carry repetitive loading of different axial loads moving on the pavement during its design life, so take the care of the fatigue failure. So these all design consideration are very important to be taken into account before going for concrete overlay. We should know the complete characteristics of the existing pavement and the nature of the environment, so that we can make a proper choice of overlay. Okay, now, once we evaluate the pavement, made the choice of type of overlay I shall opt for, and identify and mark initial design considerations, the final step is the application of concrete overlay. The application step again has four parts: making the choice of material for overlay, then choosing the ingredients for that material, then carrying out pre-overlay treatment, and finally paving the overlay. Okay, so first part, choice of overlay material. So choice of overlay material, it depends upon specific project requirement, existing pavement condition, and budget consideration. Ideally, the overlay material should be of compressive strength more than 40 MPa at 28 days. Okay. So this is a general consideration of material that we are using. Now we can use different kind of overlay material. It can be plain cement concrete, it can be fiber reinforced concrete, it can be high performance concrete, it can be high performance fiber reinforced concrete, can be high strength concrete, or it can be self compacting concrete. The choice of the material, it depends upon the requirement of the strengthening, the condition of the pavement, and the budget considerations that we have. Okay. Now, depending upon the choice and the grade of the overlay material that we made in the first step, the ingredients can vary. Some of these ingredients and their specifications are, though we have basic ingredients that are cement, sand, coarse aggregate, and water. We may use chemical admixtures like water reducing admixture, which has limited percentage of low of use to maximum 2%, or we can use air retaining agents, which can be used up to maximum 6.5% by weight of cement. We can always use mineral admixtures like SCMs to enhance the performance of my pavement. We can use fly ash, GGBFS, ground granulated blast furnace slag, or silica fume. And in case of fiber reinforced concrete, we may use fibers up to 2.2 to 0.4% by weight of cement. Okay, the choice of fiber can be polymeric fiber, macro polymeric fiber, or macro steel fibers. And these fibers are the generally used fibers are say 10 to 70 micron in diameter, having specific gravity in this range, water absorption and melting point satisfying these criteria. And the basic need from these fibers are, they should not form a fiber ball, and they should not adversely affect the properties of concrete. So taking into consideration all these limits, we make the choice of the material ingredients. Once the choice of material ingredient is done, the next step is the pre-overlay treatment that may be required in case of some overlays where, like in case of bounded overlay or ultra thin or thin white topping. In such cases, we require pre-overlay treatment. So the extent of pre-overlay treatment, it depends upon various factors. It depends upon the extent of degradation in pavement, type of degradation, and type of material in existing pavement. For example, in bitumen pavement, Conventional white topping doesn't require pre-overlay treatment. Okay, while ultra thin and thin white topping requires adequate surface treatment. Okay, so here you can see different types of failure or distress in the pavement. They require different kinds of treatment method for pre-overlay treatment. Like for rutting, we may need milling or leveling. For shoving, we may need milling, and similarly for transfer and longitudinal cracking, we may not need any kind of pre-overlay treatment, but we need grouting so that we can fill these cracks. Okay, or when there is subgrade failure, it is important to remove and replace and then repair. Okay, now this pre-overlay treatment is generally carried out in three steps. First is milling of top surface, then second is repair of existing pavement, and third is cleaning of the surface. So when we talk about milling of top surface, the aim is to prepare the surface to remove any damaged bituminous layer and to make surface rough and uniform. This can be done either by using milling machine, hand grinding, or light chiseling. And the depth of milling, it generally varies between 25 mm to 75 mm depending upon the extent of damage in the pavement. And after milling, minimum thickness of 75 to 100 mm of bitumen shall be retained. Else, a bitumen layer is poured for additional getting the additional thickness. So here you can see hand grinding is done for milling the surface, and here you can see an additional bituminous layer is poured on the surface. Okay, after milling. Second is repair of existing pavement for any kinds of cracks. So this is done to fill local patches like cracks and potholes. Okay, for this dense bituminous mixture are used to reduce reflection cracking, and the conditions it requires the top part of the milled surface and the repaired surface should be at the same level. So after filling the crack, it should not appear like a hump on the surface. It should be in the level with the pavement. Okay, and if used for profile correction, the minimum thickness of 50 mm shall be provided to milled surface. So here you can see in this image, longitudinal and transverse cracking are filled using bituminous mixture. Here you can see again different small cracks are filled due to using bituminous mixture, and here you can see a pothole been filled and tapped properly for leveling it till the surface. Okay, and finally, the last thing is to clean. That is removal of any loose material, dust or debris from the surface which can affect the bonding. Okay, this is done to ensure adequate bonding between the milled surface and the overlay, and it can be done either by using manual brooming or power brooming, or by air blasting, water blasting, or sand blasting. So here you can see water blasting is used. Here you can see air blasting is used, and again here you can see water blasting is equipped to clean the overlay surface before going to clean the pavement surface before going for any kind of overlay treatment. Okay, once all the treatment are done, we can lay our overlay. So the that laying process of overlay it is also known as paving of overlay, and it is generally divided into different steps. So first step is the pavement of concrete mixture. Second step is compaction of that mixture. Third step is finishing of that mixture. So we first pour the mixture. Okay, we compacted that mixture over the surface. Then we'll finish that mixture from the top. Okay, then we'll cure this top surface either using gunny bags or using curing compound. Then we'll form construction joints at the surface, longitudinal and transverse joint at the surface, and finally we'll use saw cutting to make joints. Okay, now, for this initial step, placement of concrete, there are two types of devices that are used: slip foam pavers and fixed foam pavers. So, fixed foam paver rely on stationary foams to shape the pavement, while slip foam pavers allows continuous movement during the paving process. So, here you can see in this fixed foam, it is fixed from the side. Okay, and the concrete overlay is paved using this foam on the surface to achieve a adequate thickness of the overlay. Okay, while in slip foam paver, it is movable on the side, so it continuously pours the concrete, it levels it at the top, and it compacts also. So internally there are vibrators in this pavement which helps us to compact the pavement. Okay, So, in case of slip foam paver, those that can move or slip during the pavement process, and they don't require any steel or wooden foams. While in the fixed foam paver, they are side foams that are used to hold the concrete in place at a proper grade and alignment until it sets or hardens. These are the properties of both the pavers. Okay. I hope everyone are clear with this part, how the placement of overlay is done. If yes, try to identify these steps in the images that are shown on your screen. Okay. We have discussed completely what are different types of overlay, how we take different design consideration while designing overlay, and how we place the overlay. Okay, so try to identify these steps as shown in the figure. Okay, I will take a pause for 2 minutes. In the meantime, if you have any doubts related to any content in this session, you can ask by posting your queries in the chat box. Okay. So this pavement part, it is like relatively very simple part. Okay, we saw a lot of these things earlier also in terms of repair. The only new thing that might have come to you is this last part, the paving part. So that's why I've tried to detail this application of concrete overlay as much as possible so that you can get a better clarity. You can, if you have any doubts, you can write your questions in the chat box, and I will freeze my screen to the question, to the slide, so that you can solve it. So let's see this question now. Okay. So the first image, you can see fixed foam paver that was used. Okay, so the foam paver, paver was fixed at a location, and then the concreting was done using this mixing batch, a mixing truck, and it was vibrated using the paver only, and using external vibrators also are used for this pavement process. Here you can see in the second image. Okay, so the concrete is poured using the fixed foam paver, and external vibrators are also used in some locations. Okay, for vibrating and compaction. Second step was bull floating, that was done to give some overlay treatment or overlay patterns. Okay, then we have texturing that was done on the pavement. Okay, this was done to level the pavement, this was done to texture the pavement. Then saw cutting was done to provide transverse joint and longitudinal joints. So before this, we marked the overlay surface properly so that the spacing between the joints can be adequate. Okay, once everything is done, we will see a finished surface like this. Okay, so this is all about concrete overlay as a repair or a retrofitting technique for pavement repairs. Any doubt in the discussion today?